Hello everybody and welcome to Homework Helper for section 8.5. Today we're going to be doing some things that are a little bit different and kind of preparing us for our next unit, which is going to be a little bit more on data analysis. One of the things we're going to be doing in this first section here is we're going to be talking about this idea of spread when we're looking at data. So it says look at the spread of the histogram below, and well, below is actually right here, it's not really below. So a histogram is just a bar chart like this. And so there are multiple ways that we can describe what's going on in a data set, especially when we're talking about concepts of spread. One of the ways that we can kind of talk about it is in terms of this idea of skew. Now, skew means to slide one way or another. And so, for example, this appears to be, if I were to draw an arch like this, it appears pretty close. Like, yeah, there's a little bit more on the right side, but it's not significant. So I would call this a slight right skew. It's somewhat towards the right side of our bar graph, because we can see, like, here's our midpoint, and we kind of overlap it a little bit more than we do on the left side. So it's a slight right skew. You can kind of imagine, data sets, going like this. That would be a left skew, and this would be left. This would be even, and then this would be right. Whoops, let me do this correctly. Rightly. Okay, so that would be right. And so this is kind of in between even and right. So that's why I would use the word slight to describe the skew. Another thing, it appears that I have frozen. Let's unfreeze me. How about that? Let's close you. Let's reopen you. Am I back? Nope, that's just a photo. Hey, technical difficulties. I do not want to save this. Let's try this guy. Hey, we're back. Okay, cool. What was I saying? Skew. Cool. Awesome. Another way that we can kind of look at data is in terms of quartiles. And so quartiles, what ends up happening is what we end up wanting to do is we want to split our data set into quarters, right? We're going to have 4 quarters, quarter 1, quarter 2, quarter 3, and quarter 4. And so when I look at this, I try to figure out what exactly is going on. So I'm going to call this 60, 65, 70, 75, 80, 85. And I'm not actually going to include 90. 90 is going to be over here. And so I see that I have 3 60s, so that's 60, 60, 60. 3 65s, 65, 65, 65. What is that? 8 70s. 1, 2, 3, 4, 5, 6, 7, 8. 10 75s. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. What is this? 5 80s. 1, 2, 3, 4, 5. And finally 2 85s. 85, 85. Okay. So I've accounted for all the different trees in my cherry tree height. So to figure out my quartiles, I have to figure out how many of these things I have, and then cut it up in quarters. So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31. So I have 31 data points, okay, 31 data points. And so what I want to do is I want to divide 31 into 4. So if I do 31 divided by 4, I get 7.75, or we'll just say 7. So that means my groups of 7 are going to represent my quartiles here. So that means 1, 2, 3, 4, 5, 6, 7. So that's in the middle. 1, 2, 3, 4, 5, 6, 7. That's in the middle. 1, 2, 3, 4, 5, 6, 7. That's in the middle. 1, 2, 3, 4, 5, 6, 7. So I've identified my quartile points, right? So I have, here's the first quarter, here's the second quarter, third quarter, fourth quarter. So I can see that 70, 75, and actually 75 are all within my quartile range. So I have a huge spike at 75, which of course we can see, here's the huge spike at 75. So this would be first quartile, this would be the second quartile, third and fourth quartile. And so when I look at this huge spike at 75, this is another term that we use. You guys are probably used to different ways of averaging. We have mean, where we add up all the numbers and then divide by the total numbers. So we would add up all these numbers and then divide by 31. That would be our mean score. We have median, which is the number right in the middle, which in this case is 75 because that's our middle quartile point. It's the beginning of our third quartile between our second quartile and third quartile. And then we have mode. And mode is an important one because mode means the most commonly occurring one. And in this case, 75 to 80 range, this one right here, is our mode. It happens a lot. And finally, the final thing I want you guys to think about is this concept of range. A range in data. So a range in data just means how our data is spread out. So for example, we see that we top out at 90 and we end at 60. So I would do 90 minus 60 equals 30. And so what this means is that we have a range of data of 30, meaning that our black cherry trees go anywhere from 60 feet to 90 feet. They're anywhere in that range. They're anywhere in that 30-foot range. So if we had a cherry tree that was 100 feet tall, it'd be like, wow, that's weird. Or if we had a cherry tree that was like 20 feet tall, it'd be like, wow, that's weird. But we expect our range to be within that 30 feet. Okay. So those are the things I'm looking for. I'm looking for you to talk about, let me highlight them. Skew. Skew is important. Quartiles. Identify the mode, in this case 75, and identify the range. Those are the 4 things I'm looking for you to be able to do on this. Okay, let's turn the page. Turn around. All right. You were given information about f of x and g of x. Rewrite g of x in translation form such that g of x equals f of x plus k. So when I look at this, I have f of x, I have g of x. So I know I have g of x is going to be f of x plus some k. So what I have to figure out is what I have to do to g of x to turn it into f of x. So when I look at this, what do I have to do? So negative 5 plus some k is going to equal 13. So if I add 5, k equals 18. So I know that this is going to be plus 18. Okay. And then I'll do it again here. So I know g of x is f of x plus some k. So when I look at this, I know that 213. Ooh, whoops, I did this wrong. I did this backwards. I just realized. Uh-oh. Scratch that. Right, because I'm looking at g of x is f of x plus some number. I did it backwards where I did the g of x to get the f of x. So be careful of that, because clearly even I can make that mistake. So this is all wrong. Because what I'm actually looking at is I'm looking at f of x. So I'm looking at 13 plus some k, and that has to equal a negative 5. So in this case, it's a negative 18. Simple, simple difference, but significant difference, right? Because I want to do something to f of x. I want to do something to f of x, add the k. So here's my f of x, add the k to get my negative 5. And so I can figure it out from here. So for g of x, okay, I want to take my g of x is f of x, which is negative 12, and then I want to add some k to that to get 213. So if I add 12 to both sides, I would say that it was 225. Cool, cool. And then, where are we going from here? What's next? Is that it? Is that all of our problems? Those are some easy problems. All right, let's check these out. Vertical and horizontal translation. So it's going to ask us to do things step by step. So it gives us the graph of 3x, and then wants us to do g of x, which is 3 of x minus 2. So all I got to do is go down 2, up 3 over 1, up 3 over 1, down 3 back 1. Okay, so this is the line g of x. And now wants us to graph h of x, which is 3x minus 2. Uh-oh. So now we're putting the minus 2 inside with the x, and then we're distributing the 3 to it. So let's look at what happens. This becomes a 3x minus 6. Okay? So now we have to go down 6. 1, 2, 3, 4, 5, 6, all the way on the bottom, and then we go up 3 over 1, up 3 over 1, up 3 over 1, up 3 over 1. And this produces our h of x, okay? And then you're gonna have to look at it, describe their similarities and differences, and we'll go from there. All right, that's about it. The hardest part, of course, is going to be thinking about spread, and I'm looking for these 4 things: skew, mode, quartiles, and range. Now, there's one problem, number 3, where you're not going to be able to do the quartiles this way, but it actually gives you the information already in quartiles. And actually, let me show you that real fast. So this is a box and whisker plot, and the way box and whisker plots are is they're already torn up into quartiles. So this is our lowest number. This line here represents the beginning of Q2. So this line is Q1 to Q2. This box is Q2 to Q3. Whoops, I did this wrong. This is Q1. It's early in the morning, forgive me. This is Q2. This is Q3. And then this is Q4, right? So Q1, Q2, Q3, Q4. So these are the values that break up our quartiles. Much like these box values, 1, 2, and where was it, 3. Okay guys, good luck, best of luck. Ask questions, all that good stuff. Have a good day.